a simple but good problem, conceptual problem. Whenever a body goes down, okay, generally without friction it goes down with acceleration g sine theta, right? If this angle is theta, and if there is friction, then it becomes mu g cos theta. Okay, g sine theta minus mu g cos theta. Alright, because there is a frictional force along this direction in the opposite directions with mu mg cos theta. This is very standard results. We have discussed it many times in many problems, right? Now imagine that these two bodies are going down with same acceleration. That means mu is same. These two bodies is going down with same acceleration. Then the reaction force on the surface of A and B will be 0. Okay, because there, imagine that you are running and your friend is running, both are running in same directions, and you are trying to put your hand on the back of your friends, right? So since you are running in same velocity, this your friend will not realize any pressure. That means n equal to 0. Now more interesting part will be when the accelerations are different. Suppose this A has more acceleration, that means less friction, and B has less acceleration, that means more friction. Then A will move faster and B will move slower. In that case, the contact between A and B will be the A will detach from B. That means there will be no contact in between A and B. I am coming again. If A is moving down faster and B is moving slower, then A will move fast. A will move faster, so that there is no contact in between A and B. So N will be again 0. No contact, no contact force. But in this case, B is moving faster. Why? Because mu1 is greater than mu2. That means A has more frictional force than B. So obviously B will move faster and A will move slower. In that case, by analogy, we can say that suppose you and your friends both are running. You are running with velocity u and your friend is running with velocity v. U is greater than v. Then obviously there is a push on your friend, right? Your friend will realize a push because you are running faster. This just like that. So we'll analyze this problem, okay, one by one. So let me get over all of this. Let me get some space from here. Okay, we'll draw the free body diagram of system A and system B. First, let me draw the free body diagram of system A. Okay, the system A is going in this direction with acceleration A. Both of them have acceleration A. So what is the net force in this direction? Let me write it straightforward. Okay, that the equation, suppose the contact force between B and E is N in this direction. Obviously the contact force, this is a free body diagram of A, the contact force of B on A is N. Okay, and what are the other forces? There is M1G, and there is a friction in the opposite direction, say F1, and there is a contact force N1. What is N1? N1 is the contact force by the surface on, by the sliding, I mean this inclined surface on A. Very standard, right? So we have to write here that this angle is alpha N plus M1 G sine alpha minus F1 equal to mu1, sorry, equal to M1 A. So we can rewrite this N plus M1 G sine alpha minus F1. What is F1? F1 is equal to mu 1 N1, isn't it? Now what is N1? Mu 1. N1 is m1g cos alpha. This is a very standard results if you remember. Okay, mu1 m1g cos alpha equal to m1. This is our first equation. Okay, similarly we'll get second equations for b. For b, then will act upward, because for b is giving a contact force on a downward, so it will go upward. So second force is m2g. Okay, similar kind of problem. This is n2. N2 is what? The reaction force by this surface on b, and there is frictional force over here, and this is again mu2 n2. So what we'll get? What is the component of m2g along this? M2g sin alpha minus n minus f2, right? F2 is what? Mu2 m2g cos alpha equal to m2. This is my second equation. Okay, this is similar, right? This here we are writing mu1 m1g cos alpha. Here we are writing mu2 m2g cos alpha. Okay, now we have to solve it. Let's solve it. The best way to, there are we have to eliminate a, right? So there are various ways to solve it. The best way is multiply this by m2 and m2 and multiply this one by m1, and we'll subtract it m1. Okay, and we'll subtract it, so we'll get the m1 m2a and m1 m2a will cancel out, right? So let me write it. I have to be very careful. Okay, so we are subtracting this from this, so what we'll write? N, let's take one by one. N m2 plus m1. Okay, m2 plus m1. Now we can take common m1 m2, right? So plus m1 m2, m1 m2. Let's see what we are getting, and this two will cancel out. M1 m2 g, this two will cancel out. Okay, sorry, this is a bit messy. Okay, and m1 m2, if we are taking common, what will get? M1 m2 g cos alpha. If we are taking common that, what we are getting? We are getting mu2 minus mu1 equal to 0. So n is coming what? N is coming mu1 minus mu2 g m1 m2 cos alpha divided by m1 plus m2. This is our final answer. Okay, now what's if mu1 equal to mu2? Like we said, if mu1 equal to mu2, then n will be equal to 0, right? Which is consistent what we have started with what we told in start.